Hi everyone, today we're going to be practicing solving proportions. Just a reminder, make sure that as you're taking notes, anything I write on the screen you write on your paper. This is going to be especially important for this skill, not that it's not important all the time, but you're going to want some good examples and steps to look back at for this one. So let's review. A ratio is when we compare two amounts and we usually write it as a fraction. For example, for each student, we have 4 pieces of paper. The ratio of students to paper is 1 to 4. Remember that the word each or per means the number 1. So for every one student, there are 4 pieces of paper. So the ratio is 1 to 4. A proportion is when we have two ratios, but usually a piece of one of them is missing and we are supposed to be finding it. So for example, for each one student, there are 4 pieces of paper. How many pieces of paper, that's the piece I need to find, are needed for 24 students? So if I know that for an activity, every kid in my class is going to need 4 pieces of paper, and I have 24 kids in my class, I should find out how many pieces of paper I'm going to need altogether to make sure I have enough, right? So here's what's really important when you're setting up a proportion. You're going to write your ratios in order. So, for example, if my first ratio says for each student, there are 4 pieces of paper. That means I'm going to write my one student on the top of my fraction and my 4 pieces of paper on the bottom of my fraction. Do you see how we've done that here? I have paper on the bottom and I have the number of students on the top. That comes from the first sentence of the problem. I don't even need to read the second sentence. I can write this fraction as it is. I'm going to write my division sign in between, and then I'm going to look at the next sentence to set up my next fraction. It says how many pieces of paper. So that tells me that that's the piece I don't know. Notice I'm keeping my pieces of paper color the same. And I'm also going to keep it on the same side of the fraction. So if in my first fraction I wrote the pieces of paper on the bottom, in my second fraction I'm also going to write the pieces of paper on the bottom. Now when that's the piece I don't know, I'm going to use a variable to show that I don't know how many that is. Then it says are needed for 24 students. If students is on the top of my first fraction, I'm going to put the number of students on the top in my second fraction as well. So if I have students over paper in the first fraction, I'm going to make sure I have students over paper in my second fraction. Now my proportion is set up correctly. The steps to solve are exactly the same every single time. Cross multiply, divide. Cross multiply, divide. Every single time. So to cross multiply, we multiply diagonally. So I'm going to have 1 times x, which is the same as 1x. And I'm going to have 4 times 24, which is 96. So that's step 1. I've cross multiplied. I've multiplied along the diagonals. Then I'm going to divide by whatever is next to my variable on both sides of my equal sign to get my answer. So in this case, I have a 1 next to my x. I'm going to divide by 1. Any number divided by 1 is itself. So that means my missing number in this case is 96. I will need 96 pieces of paper altogether if I have 24 students. So let's review what kinds of word problems you might come across where you can use a proportion to solve it. Any situation where you are given one comparison of numbers and you need to find part of the second is going to be a situation where you could use a proportion. So for example, my car gets let's just say 250 miles for a 10-gallon tank of gas. I'm given one comparison of numbers here. I want to know how many miles does it get per gallon. Remember that per means 1. So I can set that fraction up. 250 miles for a 10-gallon tank I don't know how many miles, but I'm going to keep miles on top because I had miles on top in my first fraction and gallons on the bottom. I don't know how many miles it gets for 1 gallon. But notice miles on top, gallons on the bottom, gallons on the bottom. Now I can cross multiply and divide. 250 times 1 is 250. And 10 times x is just 10x. That's cross multiplying. Then I want to divide by whatever's next to my variable so I can get rid of it. So I'm going to divide by 10, cross it off, divide by 10. 250 divided by 10 is 25. That means my car can drive 25 miles for every gallon of gas that I put in it. We could also have a situation where we're looking at money. It costs $50 for 5 tickets to the movies. How much does it cost? We don't know. So that's where our variable would go. For 12 tickets. So again, I would use my first sentence to set up my first fraction, my second sentence to set up my second fraction, cross multiply and divide. We often also use proportions when we're looking at recipes. A recipe for 24 cookies takes 2 cups of sugar. How much sugar? In this case, sugar is the piece I don't know. Notice I'm keeping the color coding the same as well. How much sugar am I going to need if I want to make 48 cookies? Again, I'll use the first sentence to set up my first fraction, my second sentence to set up my second fraction, making sure that I have cookies on top, sugar on the bottom, and then cross multiply and divide, cross multiply and divide. So let's take a look at some of the problems on your progress monitoring that you can use a proportion to solve. The first problem says Mr. Anderson can paint a 100-meter long fence in 3 hours. That's my first fraction. So I'm going to have meters on the top, a 100-meter long fence, and that takes him 3 hours. Then it says, how long will it take him? So this time I don't know the length of time, so that's where my variable's going to go. How long will it take him to paint a 400-meter long fence? So notice I'm keeping meters on top for both fractions, the hours, the amount of time on the bottom for both fractions, and then I can cross multiply and divide. 100 times x is 100x, and 3 times 400 is 1200. That's cross multiplying, and then I'm going to divide by 100 so I can get my variable by itself. Divide by 100, and I'm going to get 12 hours as my missing number. The next example says the distance between two cities on a map is 5 centimeters. The map uses a scale of 1 centimeter is equal to 10 kilometers. How far apart are the cities? So in this case, I know that on a map, two cities are 5 centimeters apart. But I don't know how far that is in real life. So that's where my variable goes. But I know that the scale on the map is that 1 centimeter is equal to 10 kilometers in real life. So notice I have centimeters on top on both fractions, kilometers on the bottom for both fractions. Now all I need to do is cross multiply and divide. 5 times 10 is 50. 1 times x is just 1x. And if we divide by 1, well, we get any number divided by 1 is itself. So 50 kilometers is my answer. In the last example, it says, last winter, a store sold 318 mufflers in 6 months. There's my first fraction. 318, mufflers, 318 of them, and they sold that in 6 months. I'm going to do MO for months. It says this winter the store plans to sell mufflers for 5 months. So since I made months green in the first fraction, I'm going to keep it green in the second fraction. And I'm also going to keep it on the bottom in the second fraction, just like it was in the first fraction. Based on the average number of mufflers sold each month last winter, how many total mufflers should the store plan to sell this winter? So in this case, the number of mufflers is my missing piece, my variable. Now I can cross multiply and divide. So we're going to have 6x equals 318 times 5, which is 1,590, and that's our cross multiplying. Then we're going to divide by 6 to get rid of it. Divide by 6. And we're going to get 265 as our answer. The store should sell 265 mufflers in 5 months. You're going to go ahead and do the You Try It problems. And I've kept similar problems grouped together so you can go back and rewatch just that example if you get stuck. And then if you need more practice, there are some additional practice links at the end. Happy practicing!